Hello. In this lecture, we'll discuss types of grammars, that is a Chomsky classification. So, type of there are basically type 0. So, type 0, then type 1, then type 2, and type 3 grammars. So, we'll discuss type 0, type 1, type 2, and type 3 grammars. Now, first we'll discuss the type 0 grammars. So, type 0, these are basically the unrestricted grammars. So, these are unrestricted grammars, and any kind of production can be included in type 0 grammar. Any kind of productions, can be included into type 0 grammars. Okay. So, type 0 grammar basically recursively enumerable languages are basically belongs to the type 0 grammar. So, recursively enumerable that is RE are basically type 0 belongs to type 0 grammar, and this recursively enumerable languages are also called Turing recognizable language. Now, what are the production form of this type 0? So, the production rules or the production form. So, production form is of that form alpha to beta, where alpha and beta belongs to B of n union sigma h star, and alpha contains a variable. What is Vn? Vn is basically non-terminal, and sigma basically input alphabet, it is a terminal, and alpha contains a variable. So another also we can write in that form also, alpha to beta, or we can write in this form alpha to beta, where alpha belongs to Vn means non-terminal union sigma its star, then V of n means non-terminal, again Vn union sigma star. That means in both of these case it may be empty, epsilon, it may be epsilon, so only Vn, that means non-terminal will remain, and beta belongs to Vn union sigma its star. Okay. Now What are the device or accepting device? Okay, now accepting device. So Turing machine. Okay, which basically accept this. For example, suppose S A B to B A, or suppose A to S. Yeah. So this is type 0 grammar. Another example, we can also write unrestricted grammar. So suppose G equal to a grammar where non-terminals are S, A, X. Terminals are suppose A, B, P is the production, and S is the start symbol. Okay. Now P can be defined as, and it is unrestricted. So any kind of production form basically belongs to type 0. So BA, we can write AAX, suppose BAA to ABA, or we can also write AX, epsilon, and so on. So these are basically the example. So it is example 1, suppose it is example 2. So are basically belongs to the type 0. Okay. Now, now we will discuss type 1 grammar. So type 1, type 1 are basically, this type of grammar are basically called the context sensitive grammars. So these are context sensitive, context sensitive grammar, and basically used to derive context sensitive language, used to drive context sensitive language, context sensitive language. And the production form will be of that form alpha, A, beta to gamma, where this is called the left context and this is basically called the right context, and A is basically a variable or non-terminal. Yeah. So we can define alpha and beta belongs to Vn union sigma its star, and A belongs to a variable or non-terminal, and where gamma is basically belongs to Vn union sigma its plus, that means cannot be empty. So gamma must be non-empty here. Now in type 1 production, it basically does not increase the length of the working string. That is we can write the length of the string, that is alpha A beta, that should be less than or equal to length of string gamma. Or also we can write, that is count of of symbol in left hand side is less than less than or equal to right hand side. Okay. For example, suppose the productions are of the form S2 AB, AB to ABC or B to B. So this is example of the type 1 grammar. Look here, length, left hand side, length of the string is less than or less than equal to right hand side. Clear? So less than side symbol, count of the symbol in the left hand side is basically less than or equal to the right hand side. And the accepting device for the type 1 grammar is basically a linear bounded automata. Clear? So accepting device, you can write here, accepting device is linear bounded automata. We'll discuss these accepting devices later on, like Turing machine, like linear bounded automata. But now just remember that accepting device, Turing machine, accepting device, in this case type 1 grammar, it is a linear bounded automata. Now we'll discuss type 2. Type 2. Type 2 are basically called the context free grammar. Yeah, so these are called context free grammar, and these are basically used to generate context free language. Context free language. Okay. And the production form is of that form A to alpha, where this A belongs to Vn, means non-terminal, where, and alpha belongs to Vn, this means non-terminal, union sigma and its star. For example, S to AB, A to A terminal, B to B. So on the right hand side, it is basically a combination of terminal as well as non-terminal. So this is one of the example of the type 2 grammar or context free grammar. And accepting device is basically push down automata or PDA. Push down automata, or we sometimes call the PDA. Okay. And the last type of grammar is basically type 3. Type 3 grammar. So type 3 are called the regular grammar. So these are called regular grammar. And they are basically used to generate the regular language. regular language. Regular languages. And the production form production form is of that form a to small a, that is my terminal, or a to terminal, then variable, where a b belongs to non-terminal and a belongs to sigma star, that means terminal star. Or another way, we can say that alpha to beta, alpha belongs to Vn, that is alpha is basically the non-terminal and beta belongs to, we can write epsilon union terminals, or union we can write the terminals then non-terminals. For example S to AB S, or we can write S to A. So these are basically the type 3 grammar or the regular grammar. Okay, now we uh, so accepting device, obviously we know the accepting device of the type 3 grammar are basically the finite automata. So accepting device is basically the finite automata. Finite automata. Clear? So that is we have discussed here the types of grammar. Now in summary we can write in that way that type regular grammar, we can write that is regular grammar is this, and then context free regular, not regular grammar, rather we can write a regular language here. Regular language, context free language, okay, and then context sensitive language, then we can write recursively numerable, recursive numerable language. So we can broadly write in that way. So now this outer mode, it is basically type 0, and it is basically type 1, and it is basically type 2, and it is basically the type 3. And from type 0 to type 3, type 0 is basically most unrestricted grammar, but type 3 is basically the restricted grammar. So thank you.